Our journey into hobbyist 3D printing begins with a very big idea. This idea was called the RepRap project. Dr. Adrian Bowyer started it back in 2005 at the University of Bath in the UK. The goal was simple but honestly pretty amazing. Create a machine that could print its own parts. This would be a self-replicating manufacturing machine. Imagine a printer that could actually make another printer. That was the core of the RepRap dream. It wasn't just about making things, it was about giving everyone the power to make the tools they needed. This open-source philosophy really became the foundation for everything that came after. The first successful RepRap printer was called Darwin. It showed up in 2007. Darwin, well, it wasn't pretty, and it definitely wasn't fast. It was built out of threaded rods, nuts, and most importantly, 3D printed parts. Anyone with the files could just download them for free. Then they could buy the non-printed parts like motors and electronics and build their own printer. This was, honestly, a revolutionary concept. Before RepRap, 3D printers were super expensive machines found only in big companies or universities. Suddenly, a small community of makers and thinkers all around the world could build their own. They could also improve the design and share their changes with everyone. This sharing culture was the most important part of the RepRap project. The designs were licensed under the GNU General Public License, or GPL. That meant anyone could use, change, and distribute the designs, but they had to keep the new designs open source too. This created a really fast cycle of innovation. People from all over the world worked together. They fixed problems, added new features, and made the printers better. The community became kind of like a global research and development team. Every improvement was a small step forward for everyone. From this shared pool of knowledge, a bunch of new printer designs would eventually emerge. The early RepRap printers, like Darwin and later Mendel, taught us a lot of the basic principles. They used a Cartesian coordinate system, moving an extruder in X, Y, and Z directions. They pushed plastic filament through a heated nozzle to build objects layer by layer. This whole process is called fused deposition modeling, or FDM, and sometimes fused filament fabrication, FFF. While these first machines were definitely tough to build and calibrate, they proved that low-cost, open-source 3D printing was totally possible. They really were the spark that ignited a worldwide movement. Without the RepRap project and its open-source spirit, the affordable 3D printers we use today just wouldn't exist. From the fertile ground of the RepRap community, new companies started to grow. One of the first and most famous was Makerbot Industries. Founded in 2009 by Bree Pettis, Adam Mayer, and Zach Smith, Makerbot wanted to make 3D printing way more accessible. Their very first kit, the Cupcake CNC, was a direct descendant of the RepRap project. It was sold as a kit you had to assemble yourself. The frame was made out of laser-cut plywood. That was a pretty big change from the threaded rods of the early RepRap printers. The plywood frame was just easier and faster to put together, which opened the door for more people to get involved. The Makerbot Cupcake was a huge step forward in user-friendliness, even if it was still a bit of a challenge to build. It showed that there was definitely a market for 3D printer kits. People were excited about this new technology, and were willing to spend time and money to have a 3D printer in their home or workshop. The Cupcake wasn't perfect though. It didn't have a heated print bed, so printing with some materials like ABS was really tough. Warping was a constant problem, but it built a strong community around it. This community created Thingiverse, a website where people could share their 3D models. Thingiverse became a massive library of things to print. Makerbot learned from the Cupcake and soon released their next model, the Thing-o-matic, in 2010. This printer included a super important innovation, a heated build platform. That was a total game changer. A heated bed keeps the bottom layers of a print warm, which really reduces warping and helps the print stick to the bed. Suddenly, printing with ABS plastic became much more reliable. The Thing-o-matic also had a conveyor belt system for its build plate, which was an experimental idea to allow for continuous printing of parts. While the conveyor belt didn't become a standard feature, the heated bed definitely did. It's now a standard on almost every FDM printer. The Thing-o-matic was still a kit, but it was more refined than the Cupcake. The instructions were better, and the parts just fit together more easily. Makerbot was learning how to turn a hobbyist project into something more consumer-friendly. These early Makerbot printers, built on open-source principles, were absolutely crucial. They popularized the idea of desktop 3D printing. They built a community and a platform for sharing files that people still use today. Even though Makerbot later moved to a closed-source model, their early contributions showed the world what was possible and paved the way for the printers that would follow. While most early printers were based on the Cartesian system, some innovators were exploring totally different ways for a printer to move. One of the most interesting results was the Delta printer. The design was based on the Delta robot, which was invented in the early 1980s for fast pick-and-place tasks. Johann Kossel adapted this concept for 3D printing in 2012 with his Rostock printer. The idea was to create a fast, light, and elegant machine. From the Rostock, a smaller and more popular version was born, the Mini Kossel. It quickly became a favorite in the RepRap community. Unlike a Cartesian printer which moves its print head along rigid X and Y axes, a Delta printer uses a totally different system. The print head, or effector, is suspended by 3 arms. These arms are connected to carriages that move up and down on 3 vertical pillars. By precisely controlling the height of these 3 carriages, the printer can position the nozzle anywhere inside its cylindrical build volume. This design, called Delta Kinematics, has some unique advantages. The moving parts are very light, because the heavy motors that drive the movement stay fixed at the bottom or top of the frame. This allows for super fast travel speeds and acceleration. Building a Mini Kossel was a popular project for hobbyists who wanted to try something new. The design was of course open source. People really loved the way Delta printers looked when they were printing. The effector seems to dance and float above the print bed as it quickly lays down plastic. Because of their speed, Delta printers were great for printing tall, vase-like objects. However, they also had some challenges. Calibrating a Delta printer was much more complex than calibrating a Cartesian printer. The math behind the movement is pretty complicated, and any small error in the build, like arm length or tower position, could lead to distorted prints. Despite all the calibration difficulties, the Mini Kossel and other Delta printers taught the community a lot. They pushed the boundaries of speed and introduced a bunch of people to alternative kinematics. They also highlighted just how important a rigid frame is, since any flex in those tall towers would affect print quality. The experience gained from building and tuning these machines helped firmware developers create better calibration routines. Features like auto-calibration, which are now common, were first developed to handle the complexity of Delta printers. The Delta printer remains a popular design, especially for those who value speed and a unique mechanical challenge. In 2012, the RepRap community saw the release of a new design that would become one of the most important and influential in history. I was working on improving the previous Mendel designs, and I wanted to create something simpler, cheaper, and easier to build and service. The result was the Prusa Mendel, and after a few iterations, the Prusa 1.3. The goal was to take all the lessons learned from the community and put them into one simple, robust, and accessible package. The i3 design used a familiar Cartesian system, but with a key difference. The print bed moved back and forth for the y-axis, while the extruder moved side to side for the x-axis and up and down for the z-axis. This bed-slinger design had a major advantage: simplicity. By separating the axes this way, the frame could be made much simpler. The original Prusa 1.3 used a single-sheet frame, which could be cut from aluminum or acrylic. This made the printer very rigid and easy to assemble compared to the complex threaded rod structures of older RepRaps. The open frame also meant that every part of the printer was easy to see and reach. If something went wrong, you could easily get to it to fix it. This focus on ease of use and maintenance was a core part of the design philosophy. We wanted a printer that people could not just build, but also understand and improve. The Prusa 1.3 was fully open source, following the RepRap spirit. We published all the files and instructions online for free. This allowed a huge number of people and companies to create their own versions and kits. The i3 design became a global standard. For years, if you bought a budget 3D printer kit online, it was very likely to be a clone or a variation of the Prusa 1.3. This huge adoption created a massive ecosystem of parts, upgrades, and community knowledge. It made 3D printing cheaper and more accessible than ever before. The design became the new baseline for what a hobbyist 3D printer should be. Over the years, we kept improving the i3 design with our official original Prusa Y3 models. We introduced features that became industry standards. We developed the first auto bed leveling using an induction sensor on a consumer printer. This saved users from the frustrating process of manually leveling the print bed. We also pioneered the use of flexible, removable spring steel sheets with a PEI surface. This made it incredibly easy to remove prints from the bed. Just bend the sheet and the print pops right off. Each innovation was focused on making the printing experience more reliable and less frustrating for the user. The i3 proved that an open-source model could produce a world-class, user-friendly product. While the Prusa 1.3 design set a new standard, our official printers were still a significant investment for some beginners. The market was really ready for a machine that could offer good enough quality at a rock-bottom price. In 2018, a Chinese company named Creality launched the Ender 3. It was not a revolutionary printer in terms of technology. In fact, it was heavily based on the open i3 bed slinger design. But, what made the Ender 3 a phenomenon was its price. It was one of the first truly capable 3D printers available for under $200. This incredibly low price point just blew the doors wide open for a massive new wave of users. The Ender 3 made a few smart design choices to keep costs down. It used a frame made from aluminum extrusions. This type of frame was strong, cheap to produce, and easy to assemble. It was a clever evolution of the single-sheet frame concept. The printer came as a semi-assembled kit. The most complicated parts were already put together, and the user only had to finish the final assembly. This saved on shipping costs and labor, but it was still much easier than building a printer from scratch. This balance of low cost and reasonable assembly difficulty was honestly the key to its success. It was the perfect first printer for people who were curious, but not ready to spend a lot of money. The Ender 3 was not perfect, of course. To reach that low price, some compromises were made. The components were not always the highest quality. The included print surface was often uneven, and the extruder could be unreliable. However, this is where the community really stepped in. Because the Ender 3 was so popular, a gigantic community of users grew around it. They shared tips, tricks, and most importantly, designed countless upgrades. You could find 3D printable files to improve almost every part of the Ender 3, from filament guides to cooling ducts. You could also buy affordable upgrade parts like better springs, all-metal extruders, and glass beds. The Ender 3 became more than just a printer, it became a platform for learning and modification. It taught a generation of new users the fundamentals of how a 3D printer works because they were constantly tinkering with it and improving it. It was the ultimate entry-level machine. Its success showed the industry the sheer size of the potential market for low-cost printers. This massive volume also drove down the price of components like motors, hotends, and control boards for the entire industry. The Ender 3 did not invent new technology, but it democratized access to it on a scale that had never been seen before. As the hobby matured, a group of advanced users wanted something more. They were just not satisfied with the speed and quality limits of the typical i3 style printer. They wanted to build a high-performance machine without any compromises, and well, they were willing to put in the work to get there. This desire led to the creation of the Voron project in 2015. Voron is not a company that sells printers. It is a community-driven open-source project that provides a set of designs for building top-of-the-line DIY 3D printers. You cannot buy a Voron printer, you have to source the parts and build it yourself. The Voron project has several printer designs, but two of the most popular are the Voron 0.2 and the Voron 2.4. The Voron 0.2 is a small, incredibly fast cube printer. It uses a traditional Core XY motion system where the print head moves in the X and Y plane and the bed moves up and down for the Z axis. Its small size and light moving parts allow it to print at very high speeds and accelerations with amazing quality. The Voron 2.4 is a larger, more complex machine. It features a unique design where the entire gantry moves up and down on 4 belts, while the print bed remains completely stationary. This design eliminates any issues with print quality caused by a heavy moving bed. What truly sets Voron printers apart is their focus on premium components and advanced features. The designs call for high-quality parts like linear rails for smooth motion, instead of cheaper wheels on extrusions. They are designed to be fully enclosed, which is essential for printing high-temperature materials like ABS and ASA. The Voron 2.4 even has a clever quad gantry leveling system. It uses 4 independent Z-axis motors to automatically tram the gantry to be perfectly parallel with the print bed, resulting in a perfect first layer every time. This is a level of engineering not typically seen on consumer machines. Building a Voron is a serious commitment. It requires sourcing hundreds of individual parts from different suppliers and following a detailed assembly manual. But the community support is incredible. The Voron community uses Discord to provide help, share modifications, and showcase their amazing builds. A key part of the Voron experience is also the use of Klipper firmware. Klipper uses a Raspberry Pi for heavy processing, which allows for more advanced features like input shaping. This feature measures and compensates for the printer's own vibrations, allowing it to print much faster, without the ghosting or ringing artifacts. The Voron project represents the pinnacle of what a dedicated open-source community can achieve. For many years, the world of hobbyist 3D printing was a story of gradual improvements, mostly led by the open-source community. Then, in 2022, a new company called Bambu Lab launched a product that changed expectations overnight. Their X1 carbon printer was a shock to the system. It was a fully assembled, enclosed printer that was faster, smarter, and easier to use than almost anything else on the market. Bambu Lab was founded by former engineers from DJI, a leader in drone technology, and they brought a new level of engineering and integration to the 3D printing world. The Bambu Labs X1 Carbon, or X1C, was packed with features that were previously only found on high-end industrial machines or complex DIY builds like the Voron. It used a Core XY motion system and linear rods for speed, and it could print at astonishingly high accelerations. It came with a built-in LiDAR scanner that automatically leveled the bed, calibrated the filament flow, and even performed a first-layer inspection. This removed some of the most difficult and frustrating parts of the printing process. The printer was truly plug and play. You could take it out of the box and be printing high-quality parts in minutes. One of the most impressive features was the Automatic Material System, or AMS. This was an optional add-on that allowed the printer to automatically switch between 4 different spools of filament. This made multicolor or multi-material printing incredibly easy. Before the AMS, multicolor printing was a very difficult process that required a lot of tuning. Bambu Lab made it a simple, one-click option in their software. This opened up a whole new world of creative possibilities for everyday users. They later released more affordable models like the P1P and P1S, which offered the same core speed, but with fewer of the advanced automatic features. Bambu Lab's approach was different from the open-source tradition. Their printers are closed-source, much like modern smartphones or appliances. You cannot easily modify the hardware or firmware. This was a controversial change for many in the community who grew up with RepRap and Prusa. However, the sheer performance and ease of use were undeniable. Bambu Lab showed what was possible with a tightly integrated system of hardware, software, and firmware. They raised the bar for speed, quality, and user experience, forcing the entire industry to innovate faster. Their success proved that many customers were willing to trade openness for convenience and performance. Even a new printer like the H2D is pushing the boundaries of what is possible. The rapid innovation sparked by companies like Bambu Lab has pushed everyone to step up their game. We are now seeing a new generation of printers that combine the latest technologies with sleek designs and even more advanced features. A perfect example of this next wave is the newly announced Elegoo Centauri Carbon. Elegoo is a company well known for making popular and affordable resin printers, but with the Centauri, they are making a bold statement in the FDM market. This printer aims to compete directly with the high-speed, feature-rich machines that have recently become the new standard for serious hobbyists. The Elegoo Centauri Carbon is built for speed and rigidity. It uses a strong, all-metal frame and a Core XY motion system, which we know is ideal for fast acceleration without sacrificing quality. The carbon in its name refers to the use of carbon fiber rods for the X-axis gantry. Carbon fiber is incredibly light and stiff. Using it for the moving gantry reduces the weight that the motors have to throw around. This allows the printer to reach even higher speeds and accelerations while minimizing vibration and ringing artifacts. This is a premium feature that shows a clear focus on pushing performance to the absolute limit. Like other modern performance printers, the Centauri Carbon is packed with smart features designed to make printing effortless. It includes an automatic bed leveling system that probes the bed to create a perfect first layer. It also incorporates flow rate calibration and vibration compensation, technologies that were pioneered in the DIY community with Klipper and then commercialized by Bambu Lab. These systems work together to ensure that the printer is always perfectly tuned without requiring the user to have deep technical knowledge. The goal is to let the user focus on creativity, not on calibration. The Centauri Carbon also signals a trend towards a more polished, consumer-friendly product. It is a fully enclosed printer, which is great for printing advanced materials and also improves safety and reduces noise. The design is sleek and modern, looking more like a high-tech appliance than a hobbyist kit. It is clear that the market is shifting. While the spirit of DIY and tinkering will always be a part of the community, many users now expect a printer that works perfectly right out of the box. The Elegoo Centauri Carbon represents this new standard, combining lessons from open-source projects and closed-source innovators into one powerful machine. Looking back at the evolution of hobbyist 3D printing is like watching a technology grow up in fast forward. It all started with the RepRap project's idealistic dream of a self-replicating machine, built on a foundation of open-source collaboration. This spirit gave us the first printers that people could actually build at home. Early pioneers like Makerbot took these ideas and packaged them into kits with plywood frames, making them a little easier to access and introducing the crucial heated bed with the Thing-o-matic. The community was buzzing with new ideas, exploring different paths to create better machines. The journey took us through exciting experiments like the mini Kossel Delta printer, which chased speed with its elegant lightweight design and taught us valuable lessons about complex kinematics and calibration. Then the Prusa 1.3 arrived and simplified everything, creating a robust, easy-to-service open-source standard that dominated the market for years. This design was so successful that it was adopted by companies like Creality, whose Ender 3 brought the price down so low that millions of new users could join the hobby. Each of these steps was built upon the last, with ideas and improvements flowing freely through the community. The rise of the DIY high-performance scene with the Voron project showed the community's desire for speed and quality, introducing advanced concepts like Core XY kinematics, linear rails, and Klipper firmware to a wider audience. This set the stage for the industry to be completely shaken up by Bambu Lab. They took these high-end features, polished them into a seamless user experience with things like LiDAR calibration and multi-material printing, and delivered it in a closed-source but incredibly effective package. This pushed the entire market forward, leading to the latest generation of printers like the Elegoo Centauri Carbon, which blends speed, intelligence, and premium materials. From a collection of printed parts and threaded rods to a sleek, intelligent appliance that prints at incredible speeds, the progress has been breathtaking. We've moved from manual calibration to automatic everything, from bare frames to fully enclosed systems, and from slow, basic firmware to intelligent software that compensates for the physics of the machine itself. The goal has always been the same: to make printing easier, faster, and more reliable. Whether through open-source collaboration or competitive commercial innovation, every step has brought us closer to the day when this amazing technology is as common and as simple to use as a regular paper printer. The journey is far from over,